Yeah, good evening. My name is Prem Sethi. I am from Khushi Communications. Uh, this is a new company. Uh, we are going to complete 10 years this month, though personally I have experience of more than 30 years in this industry. But with Khushi Communications, we are still growing. In the last 10 years, I would say we have been quite successful with our success stories across different market segments, where we have sold our solutions, our products across different markets. We are actually the suppliers of telecom solutions where we have arrangement agreement with multiple OEMs for different technologies, for different products. Okay, so specific to data center applications, I would like to focus, or I would like to talk about three key product areas which we are focusing on data centers. One is the timing and sync. In data centers, we have seen we have servers, we have monitoring solutions, several devices which requires time. So if these devices are not accurately time stamped, then most likely those devices will not give the right information. Many times, most of these applications will also not run. So one of the most preferred protocol for timing being adopted in data center is NTP. So usually we have NTP and PTP, two protocols which we deploy in telecom solutions, in telecom networks to achieve accurate timestamps, which is traceable to UTC. And from there, we derive timing through satellite signals. We have GNSS receivers at ground stations, put antennas, and then distribute time across the networks. So still most of the data centers, I would say many of the data centers are still synchronizing their timing applications either with internet timing or with software-based solutions, which are not accurate. Recently, there has been a mandate from Government of India that data centers are required to be implement hardware-based GNSS solutions where they can also track timings from NAVIC constellations. So NAVIC is basically satellites, launched by ISRO. So the mandate is we should not have any dependency on satellites which is being controlled either by US or Russia or other countries. So now with NTP server, which will be hardware-based solutions having GNSS receiver chips and other electronics oscillators inside the box, will deliver accurate times to all the elements within data centers, which requires accuracy in milliseconds. So when it is a requirement of timestamps with few milliseconds traceable to UTC, then I think NTP is more than sufficient. But for applications, where we need timestamps accuracy in the range of microsecond or in nanoseconds, like we do in 5G, 4G networks in wireless applications, there PTP is the most preferred protocol. More or less hardware remains same. It is the license and some electronics, inside the box, which makes a difference. So that is one part of solutions which we are doing now for a lot of data centers in India. Second is test and validations. We know that, within data centers, we are talking about high-speed networks, large bandwidth, and very low latencies. So when we are talking about high-speed communications within data centers, and even sometimes it is more desirable or required for data center interconnect. So these high-speed net links, which usually are 100 gigabit per second, 400 gigabit per second. Sometime it goes up to 800 gigabit per second, along with a lot of fibers, lot of passive components like transceivers, DAC and AOC cables. So all these elements along with high-speed Ethernet links needs to be tested and validated with respect to latency, and a lot of other parameters. And third part of our product group, which we focus for data center application, is a deep network visibility. So if we want to have end-to-end visibility within data centers, we have to first tap the traffic. So there has to be traffic access points. Then once we tap the traffic, then those traffic and data points needs to be managed and optimized, so that it can be accurately used by different monitoring and analytical tools within the data centers. And third part is of course network performance analysis, including monitoring tools, analytics tools, which takes care of not only the performance but also the security parameters also, including some malicious attacks. They also detect if there are some attacks which can impose problems for security issues for any data center. So I'm going to be quick now because we have a limited time, and I know we want to rush in few minutes for our drinks also. So I would like to focus a few slides about deep network visibility, what kind of solutions we have, and how it helps data centers to achieve the complete visibility. So first is the traffic access points. They are physical devices. They are fail-safe. Even if it fails, it can still doesn't disturb the traffic. They are passive devices, so we don't have to power up. They don't interfere with the traffic. We just mirror or copy the traffic, which is flowing, and then tap the traffic and give it to monitoring solution, monitoring and analytical solutions. So taps usually come in different form factors, in different variants. There are fiber taps, copper taps, and we have aggregation taps, bypass taps, and even some software-based solutions which are normally deployed in virtual environment. Those are virtual taps. So depending upon the application, depending upon the requirements in data centers, so these taps can be deployed at multiple points, where purpose is to tap the traffic without disturbing it for monitoring and analytics purpose. So this is the typical scenario where we can see all the elements and shows we can have these taps installed anywhere where we want to tap the traffic. It can be in the cloud through software-based solutions which are virtual taps, or we can take it to the user level at the access point, where we can, if you want to tap some applications, being specifically used by some users. So these are, the typical connectivities of taps. So you can see for one link monitoring tabs, we have two network ports and two monitoring ports. A and B are network ports, and then for monitoring also, A and B, you can see in one of the pictures in the bottom right. The tab is inserted between router and switch. The link is going through network ports, and the same traffic is being mirrored, being copied, and sent to performance analysis tools. So another variant of tap is bypass, because many times what happens we have a firewall, and this firewall has to be inline in the traffic, and so we have to tap the traffic inline. So basically, then we have to bypass the traffic, and it goes through firewall, and there is a communication, through heartbeat between tap and appliance, which keeps telling tap all the time that appliance, which is the firewall, for example, in this case, is running. In case, due to any reasons, if appliance is down, heartbeat signal doesn't received by tap, and it will then bypass the signal from network device A to network device B. Once we have the traffic, being tapped at multiple locations, those, traffic has to be optimized and monitored. So normally, this is done by network packet brokers or network traffic aggregators, and this sits behind tap, but in front of monitoring solutions. So basically, a piece of hardware that sits between tap and performance monitoring devices. It optimizes the traffic in the sense that we can aggregate or we can replicate the traffic. For example, if we have multiple connections, multiple tap point, and if you want to aggregate and send all the traffic to one specific performance monitoring tool or forensic tool, or maybe for audit purpose, for security purpose, we can route the entire traffic towards one performance or analytical tools. Similarly, we can replicate entire traffic, for example, through multiple ports. So that means we can have multiple in, one out, or one in, multiple out. And it will also help us to filter the traffic based on the applications, based on the IPs, for example, or we are running. We don't have to pass entire traffic which we capture to monitoring to devices, because sometimes it will be too much of data for monitoring tools to handle, and many times they are license based, and if you pass on every information to monitoring devices, it will be too much for them to handle. So you can apply filters, and then you can decide specific destination or source address data has to be monitored, or if you want to see that certain applications for specific users you want to monitor. So these kind of filters you can apply through network packet brokers, which helps in optimizing the data flow. And finally, we have seen the traps, we have seen the packet brokers which optimize the data flow. And now finally we have a device which is IOTA. In this device, we probe, we capture, we store, because it has built-in hard disk, and it analyze. So basically, with these solutions, and it also comes in a different variant. We can have a tabletop version, small, handheld version, and we can also have rack mount solutions, and we can have multiple ports depending upon the requirements of the customers. And then solution comes with software that is installed on the PC or laptop, that gives the dashboard. On the dashboard, we see all the information related to all the IPs, which is being monitored, all the applications, and based on the filtering we apply, we can monitor, we can see the performance of entire data stream. Another point is, because it has a hard disk, of course it does real-time monitoring, but it can also do historical analysis. So the data, which we captures, that can also be analyzed later on. So that helps sometimes, when solutions are quite intermittent, the problems are intermittent. So in those areas, these tools are quite helpful. And finally, if we want to, for example, integrate our monitoring analytical tool with third-party devices, that is also possible, because if in any data centers, if they already have solutions like NDR, IPS, which detects the threats, or if they have devices which are there for any preventive actions, with respect to any malicious attacks. So these data points, these analysis can also be integrated for those tools. So when we bring it all together, that gives the complete visibility from the access point where we tap the traffic, then we manage and optimize the traffic through packet brokers, and finally we do the complete analysis of the traffic within the data center. And finally, you can see we can integrate entire analysis, entire traffic with third-party tool, which is NDR, IDS or IPS. Thank you so much.